folks, hello and welcome to Hydro-Dyne's webinar today. We're going to cover on-site testing, its benefits and why it's applicable to you and your facility, and how it can help optimize your Headworks design and equipment. So thank you for taking the time to check out this webinar. My name is John Walsh. I'm one of the regional sales managers here at Hydro-Dyne. Been with the team for about 5 years now. And when I meet with engineers and owners for the first time and I talk about Hydro-Dyne, who we are and how we're different from other providers of screen and grit removal systems, the two areas that I like to key in on are one, the high level of quality and operating efficiency of our screens. They have been independently tested and certified to provide the highest levels of debris removal and screening protection within the industry. And then the second aspect I like to highlight is our ability to come to your facility and do some on-site testing. And that testing will determine what the loading properties are of your specific collection system. So we're going to talk about that in a little more detail going forward. So here's what we're going to cover in our agenda. First, wastewater standards and where they stand today. The consequences of improper screen sizing, how it would, the negative impacts on your facility, the importance and benefits of proper screen sizing, what operational and financial benefits will that derive to you and your team. And then we will have solutions for improper screen sizing that we can help provide, and then we'll wrap up. So basically, we are going to cover that the right screen for your Headworks is critically important. It will provide optimal levels of protection within the Headworks and for the rest of your facility. That not all screens are created equally. Even those that utilize a 6mm grid, we'll talk about how their different designs will lead to different levels of protection. And that, thirdly, we're going to cover the collection systems and how collection systems for each facility and community will be different from one to the other. And then lastly, we're going to talk about on-site testing, what it is, and the benefits that it can provide to your facility and your team. So let's take a look at the first one there and what is happening to today's effluent standards. So basically what we're seeing trending within the industry is that tighter effluent standards are being demanded and dictated by the various state DEQs and the EPA. It's leading to stricter environmental regulations. Conversely, that's leading to advancements in the treatment technologies in order to hit those improved effluent standards. And then consequently, we're also seeing those higher volumes increase. As our communities grow and our collection systems grow, those same facilities are having to deal not only with the higher effluent standards, but higher incoming effluent. So as we talk about, when you look at the challenge that faces that municipality, there's really one of three ways they can do so. One, they can build a new facility with a new Headworks with a lot of high civil costs, high capital costs. Two, you can look at to see if you can modify your existing Headworks and your channels, so reduce civil costs, but it's still there. Or thirdly, do you have the ability to put new screening within your Headworks to process the higher influent flows with a higher level of protection? That's the option, obviously, which will have the lowest civil and capital costs. And on-site testing will provide you with the data and the ability to determine if that is possible at your facility. So if you have an underperforming Headworks, what are the pain points? What are the negative impacts to you? So basically, you're going to have reduced protection from your screening there, which is going to negatively impact your downstream processes. At the same time, you're going to have increases in equipment failure, increases in maintenance expenses, and increases in the task load for your operators. So at the same time, if you look at it more from a strategic standpoint as opposed to the tactical, you're going to have reduced life cycle for all of your downstream processes because of that reduced level of protection. And you will have increased capital costs over the life cycle of your entire facility. So, and perhaps the most important of those negative consequences is that ultimately it can cause your facility to not meet its effluent standards as dictated by your local state DEQ or the EPA. So let's discuss screen selection and the benefits it provides when you select the appropriate screen, and conversely, some of the negative aspects if you select a screen that is not appropriately sized. So on the graphic here, you can see we have a matrix. On the top there, you can see screen selection, coarse, too fine, properly sized, and then you can see some categories going across. Impact on the downstream equipment life, the equipment maintenance costs, and the screen and equipment, capital, and operational costs for its life cycle. If you have screening that is too coarse, then obviously it will have a negative impact on your downstream equipment life and the maintenance costs associated with that. More importantly, you will have lower reduced life cycle costs of your downstream processes and higher capital costs associated with that. Now, if you go too fine, seems a little odd, right? You would think, hey, we can't go too fine, but in reality you can. And there, while you would have a good level of protection for your downstream processes, when you look at the equipment maintenance aspect, your downstream processes will probably have a benefit there. But you do need to be mindful that if you've got too fine screen selection, the operator task load will increase within the Headworks, as the screen and the compactor will require more maintenance as it is too fine a screen. Conversely, you will be getting equipment that is larger in size, and so the capital costs and the civils required to accommodate that screen will be significantly higher also. If you have the optimal, properly sized screen, then going across all three of those categories, you will hit optimal in each one. Right, so you're going to still get the sufficient level of protection for your downstream processes and the benefits it provides in lower maintenance there. And at the same time, you will have a project that from a civil and capital costs is delivered where it needs to be. So we've just discussed the benefits and the importance of properly sized screenings. Let's talk about the wastewater collection systems themselves. As you all know, there is not a uniform, homogeneous design for collection systems within the United States. Each one will be uniquely different with its own characteristics that will differ from one collection system to the other. So let's take a look at some of those major factors that will be part and parcel of your collection system and how that impacts the debris that is coming into your headworks. So basically we're looking at four major factors. I'm not going to hit every bullet point on there, but just cover some of the major ones. When you look at population, obviously size and density, that's going to impact the size of your collection system and facility. Hospitality and entertainment. If you have a high level of restaurants and hotels within your collection system, that usually translates to a higher level of fats, oils, and greases coming into your collection system and into your facility. Correctional facilities, some correctional facilities will have a basic form of treatment at that facility. Others will not. So it's important to know, do you have that in your facility? And if so, is there protection or not? And then industrial facilities and seasonal population growth throughout the year. Collection systems themselves, let's take a look at those. Inflow and infiltration, I&I. Unfortunately, there isn't a system in the United States that is not impacted by that, and you will see significant swings between your lower, average, and peak flows as a consequence. Area and length of sewers. Typically, the longer your collection systems, you will see smaller debris coming in. Conversely, during storms, if you have a large collection system, you've got that first seasonal storm of the season, you're going to have that scarring effect within your collection system, and all of that debris sitting in the bottom of your sewers will typically end up in your headworks. So just be aware of that. Pump stations, storage basins, septage and fog we talked about earlier. Let me talk a little bit about the pump stations. If you have a gravity-fed versus a pump-fed system, then typically the nature of the debris that's coming into your headworks will be larger in size. So typically you'd be looking at more coarse screening than fine. Conversely, if you have a system that is primarily pump fed, then that debris is going to be broken down as it goes through each of those pumping stations. So something you need to be aware of and would expect to see to be a significant factor in the sizing and selection of your screens. Flow variations, I&I, as we mentioned again, any weather conditions variations, wet seasons, dry seasons, and water use restrictions. And then headworks design, some of the other items that we talked about, pump to gravity fed, the number of channels that you're looking at, how many of those will be bypassed, how many will have screens, if you have pre-treatment. And just those are the major factors. On-site testing will help identify what those characteristics are within your system and how that debris presents itself within your headworks and help with screen selection. So previously we had talked about how higher effluent standards are driving more sophisticated processes, and in turn how that requires a higher level of screening in your headworks. So let's talk about some of the characteristics that are going to be required of the screens that are providing that higher level of protection. So screen type and opening size. Typically a fine screen is considered to be a 6mm screen. Some of those downstream processes will require higher levels or lower, smaller grid sizes than that. Screen capture ratio. Very often what you're seeing more often in specs is a screen's capture ratio, removal efficiency, right? The ability, how much debris that screen is pulling out of the influent and preventing going downstream is called out on an equipment specification. The maximum opening size, what is the maximum opening grid? And then tighter screen tolerances. When you look at a screen, we obviously think about the grid that is in the influent and it is processing that flow. That being said, there are other parts of that screen design that are submerged and will be impacted by the influent. So when you look where the grid panels meet and where those panels meet the frame of the screen, what are the tolerances there? For Hydro-Dyne, for example, our tolerances are 0.5 millimeter. They're that small. Very often, however, you can look at a screen which has a 2 millimeter grid and their tolerances are 6 millimeters or 1/4 of an inch. So ask what is that manufacturer's tolerance, and then ask yourself, is that going to provide the appropriate level of protection for our particular system? So let's take a look at some of those processes that are requiring that higher level of screening. So when you look at membrane systems, they provide a pretty high level of effluent in terms of meeting standards that are most often seen today in various states, but they also conversely require a higher level of screening. Typically, most membrane manufacturers stipulate the screen in front of that MBR must be 2 millimeters or smaller. Cloth filters, very often you'll see a similar specification, IFAS or integrated fixed film activated sludge, and then MBRs typically require a high level of screening. In addition, some grit removal systems, specifically the stack tray systems, will call out a minimum of 6 millimeter screening within the headworks ahead of that grit system. So another component to consider there. And then really, in reality, what you're looking for those screens to provide is a higher level of protection than what you would typically see from previous screen designs, preventing influent debris, ragging, and any fibrous materials such as hair or those wipes which are referred to as disposable, which you all know are not, and all the issues that they create from impacting those technologies. So while we've talked about effluent standards increasing, and as a consequence, the downstream processes within facilities also becoming more sophisticated and improved, when you look at Headworks design and the data and assumptions that are used to size Headworks and for screen selection, they themselves have not interestingly changed that much over the last several decades. So we're going to take a look at one of the resources that WEF provides, and that is the MOP 8, Manual of Practice number 8, which is specifically for the design of wastewater treatment plant. In there are a number of studies contained within MOP 8, and one of them is the editors went out to various wastewater treatment plants and they asked, what is the typical debris load that is found in 1 million gallons of wastewater influent? And within that study, they found that there was a variance factor. Some facilities had as little as 0.5 cubic foot per 1 million gallons, and others had 35. So that's a variance factor of 70. It's pretty significant. So here I talked about just a short while ago about UKWER's testing. So UKWER is the equivalent of WEF in the United States, but in the United Kingdom. So basically they are a shared resource, a group that's providing resources and information to the community of engineers and operators that operate in the wastewater treatment plants. At that facility, or rather UKWER has access to a facility, a wastewater treatment plant, where they actually test screens. And over the last 20 years, they've tested about 60 plus screens from 18 different manufacturers, and they test them in a Headworks. They run them for 2 weeks, and they see how they perform in 2 key areas. One is head loss, what's the head loss associated with the average screen, and the other is their ability to capture and remove debris, their screening's capture ratio performance, SCR. So of all of the 60 plus screens they've tested, the most common one they have is screens where using a 6 millimeter grid. More than half of the screens tested utilize that grid size. And we have put them into the 5 major screen design types that they've tested: band screen, fine screen, spiral screen, drum screens, and slot and step screens, which are also counted as multi-rate screens. And you can see there is a significant variation. Again, all screens using a 6 millimeter grid. When you look at band and fine screens, typically they're averaging about 85%. Fine screens usually drop down to about 80%. But when you look at, say, a band screen compared to a step screen, there is a range there, a delta of 240% between their ability to capture and remove influent. So while WEF is showing that, hey, there's a significant variation between the amount of debris that is present in your collection system, UNIQUIR is demonstrating to us that there is a significant variation just with 6mm screens, depending on their grid and their design. On-site testing will help address and identify in those two key areas what the unique debris load is within your collection system. And secondly, and more importantly, what type of screen grid and size will be optimal to remove that debris from your collection system. So let's take a look at when it's appropriate, when it's a good time to utilize on-site testing for some of the projects you're considering at your facility, or if you're an engineer, some of the projects you're working on. So applications for on-site testing. One, if you're looking to have a much better understanding of the plant-specific influent and the loading properties that are present within your collection system, especially if they are leading to maintenance issues in your downstream processes for the operators and giving them a high task load. At the same time, impacting those downstream processes and their ability to meet your effluent standards in a negative way. If you're looking to do either plant upgrades, if you're looking to put in a more sophisticated downstream process that will require a high level of screening, or if you're looking to expand your flow processing capacity, and if you would require a different type of screening in order to hit those higher flows. And then lastly, if you are looking to validate the removal efficiency of the screens that you have operating in your facility. One, they could be screens that you've had in place for a number of years and you just want to see what their removal efficiency is. Or secondly, if you have equipment that you're looking to install and you want it to hit a certain level of screening to capture ratio performance. When you look at grit testing, very often on a grit removal system specification, you will see a requirement to have post-installation testing to verify that that grit removal system is removing the level and the size of grit that the spec calls out for. And we can do the same with on-site testing when you're looking at the screens within your Headworks. So let's take a look at some case studies. These are projects where we've actually done on-site testing, usually in the design phase. There was a facility in Florida experiencing major issues because their screenings within their Headworks was performing at a low level, as a consequence having a significant negative impact on the downstream processes and creating a high task load for the operators at that facility. So they wanted to determine two things. What was the operating removal efficiency, SCR, of the equipment that was in place? And then secondly, they also wanted to validate the performance of the new screens that they wanted installed to ensure that they were hitting their specification called out by the engineer and the owner. So we had two sets of testing. First was to validate the screening performance of the screens that were in place and also select a grid size and configuration that was optimal for that facility. So we conducted that first, helped the engineer identify the screen type and grid media that was required. And then we had a second set of testing once the screens that were selected had been installed to verify their performance and ensure that they were hitting the specified SCR level called out in that spec. The engineer and the owner were able to verify that the new screening equipment was hitting that particular specification, and conversely, they were also able to verify and confirm that the new screens they had installed were removing debris at a rate that was 3 times higher than the screens that they had had in place previously. Okay, so now we've looked at some of the case studies which help illustrate why you would want to utilize an on-site specific test. Let's talk at the how. How does our technology work in a general high-level view? So we'll have 3 large cases, and they contain the following key items. One will have piping, which will go down into the channel itself. It will pull influent from various levels in the water column. So we obviously have a pump. It's a variable speed pump, so we can vary the speed of there. That pump also can pass 4-inch objects, so we don't want to break down the debris that's present in your influent. We'll have a flow sensor, so we know how much flow is being processed by each grid media. And then what you see with those blue steel holders, Those are the components which hold the various grid media that we utilize to process the flow. And so, and then of course, that runs through the grid media, and then we'll have the piping that discharges the influent downstream of the screens, typically, unless you want them to go back upstream. Okay, so now you have a reasonable understanding of the equipment involved and its basic operating principles. Let's take a look at the contents of the report itself and the data that we're looking at and analyzing. So over here you can see a couple of pictures. One, you can see a graph which shows the blinding rate of the grid media being tested compared to the amount of influent that is processing. So there we're looking to see how quickly that specific grid media that's being tested will blind. A pretty key component. If it's blinding too quickly, then we know it's too small. Conversely, if it never blinds, then it's a pretty good indication that it's not capturing the amount of debris it needs to. The left side, rather, there is a 6mm perforated grid, and on the right side there is a 2mm perforated grid. And you can see how much debris that 6mm grid has captured versus the higher level of debris that is captured by that 2mm screen. It's not too surprising to see that. But what's interesting there is within the equipment, I mentioned that there are two grid media holders. And so very often we will test two different sizes. One, if it's single stage, it helps us determine what the optimal size is. But very often we'll also test to come up with testing to help determine what the optimal size should be between dual stage screening. So if you have coarse or fine screening in front of fine or ultra fine screening. And but again, this also helps provide more accurate predictions for head loss. So if you have, it will help you determine and understand the level of pumping that you will or will not require based upon your facility's hydraulic profile downstream of those headworks, in addition to identifying what are the properties and unique characteristics of the debris that's present in your system, and then in turn help identify what grid size and configuration is the optimal one for your screen selection within your headwork going forward. If you're looking at dual stage screening, one of the important aspects to pull out there is what is the head loss associated, because you're going to take a double hit. So we can correctly identify what the head loss will be for the dual stage screening you're going to select, and more importantly, what is the optimal configuration between the coarse screen and the fine screen. When we're looking at our testing, what we're looking to determine is which two grid sizes are ideally pulling out 50% of that debris. So one screen is not overworked and oversized, and conversely the other screen is not undersized. So you have two sets of screens that are optimally configured. They each come at pulling out as approximately 50-50 of the debris as possible. That way you have appropriately sized screens, your costs are controlled, and they're providing the level of protection required for your downstream processes. So in this presentation, we have covered what are the negative aspects of inappropriate screen sizing, why you would want optimal screens within your facility, and how we utilize on-site testing to help ensure you hit that goal. So in summary, basically selecting the right screen is important for the reasons we've stated. One, you're going to have a more balanced capital outlay with screen operating costs over the life cycle of that equipment. You're going to have a healthy balance of eliminating the organics while minimizing your disposal costs. And thirdly, and most importantly, not all 6mm captures or not all screens, regardless of their grid size, are created equal in terms of their ability to capture and remove debris from your influent. We talked about the collection systems and how every plant and their collection system is unique. So what is your influent and debris loading? While WEF has some guidelines, those guidelines are pretty outdated, and it's for a very small subset. Your system is going to be unique. It will not be the same as others, and just as your specific downstream processes will change. So on-site testing will help identify what is the unique property loadings that are present in your system, and what screening you need to put in place to make sure they don't have the negative impacts on your downstream processes. And then lastly, testing on-site for the right screen. By utilizing on-site testing, we can optimize and identify your screen selection to ensure that it will provide that required level of screening for your facility. and to hit those desired capture rates, and ensuring it does so at an appropriate level of capital outlay and lifecycle costs over the operational lifecycle of that equipment in your facility. So thanks again for joining us and listening to our webinar on on-site testing. If you do have any particular projects that you're working on where you're interested in having an on-site test performed to help evaluate and provide you with a specific data set that is unique to your facility and its influence rather than relying on assumptions, then please contact us. Here's our contact address and our information. We are on the web at hydro-dyne.com, or you can email us at info@hydro-dyne.com. Our phone number is 813-818-0777. And again, we're also on Facebook, LinkedIn, and Twitter. Feel free to reach out to us on any of those platforms. Thanks again for listening to our webinar. Again, my name is John Walsh, and I hope you found this informative. If you have any questions related to this subject matter or other projects, things you'd like to learn more details on, please feel free to reach out to us. We look forward to hearing from you. Thank you.